Hello, Ifra, am I audible?
Yes, sir, you are audible.
Okay. Any doubt from this part?
No, sir.
Okay. Let me give you a question related to this part. If density of mercury at 0 degrees Celsius is 13.6 gram per centimeter cube, find density at 50 degrees Celsius if gamma is 2 into 10 to the power minus 4 Kelvin inverse. Just put the above formula and try to find. Good, Ifra. Okay. This was the last part, calculation of expansion. Let me define you one more thing using this. There is anomalous behavior of water. In case of water, volume versus temperature. This is density versus temperature. Let's say this is 4 degrees Celsius. So for water, on going from 0 degrees Celsius to 4 degrees Celsius, volume decreases, but density increases. And afterward, 4 degrees Celsius and above, volume increases with rising temperature and density consequently decreases. So from 0 to 4 degrees Celsius, its behavior will be different from all different objects. So at 0 degrees Celsius, it will have some larger volume. On increasing temperature, there will be a decrease in its volume to the lowest point delta S, and then start raising up with rising temperature like this. Consequently, at 0 degrees Celsius, density will be minimum. Then on increasing temperature, density will also increases. And at 4 degrees Celsius, it will have maximum density. And then further, density decreases with rising temperature. So this is the exception only in case of water and between the range of 0 degrees Celsius, 4 degrees Celsius. Ifra, is it
Yes,
clear?
sir. Yes, sir.
This behavior of water enables aquatic life to survive in water. Let me define you how. Let's say this is surface of water in any water body, and this is seabed like this. So when temperature of outside becomes 0 degrees Celsius or less, so water will start freezing. So the top layer freezes first. I'll define you later on in heat transfer method how formation of ice would takes place. So this top layer of water becomes frozen and layer of ice will be at the highest most point since it having least density as compared to the water below it. So this further acts as insulating material or insulating shielding and protect the life of inner body or aquatic life or aquatic organism living just below it. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Next is expansion of liquid in a vessel. Suppose we have a vessel placed over burner. And there is liquid initially up to this level in this vessel. And placed over burner. So what will happen to the level of liquid on heating? Let's say
Sir,
initial level. Yes.
sir, it will decrease on heating.
Why?
Sir, because it will get evaporated.
I'm just considering before its evaporation.
Sir, it will remain.
Remain same. Water,
Sir,
in
it
case
will
of
rise
water,
due to kinetic energy.
due to kinetic energy.
Or
Okay,
then it will heat.
just think, on supplying heat from this part, which will receive heat first, the vessel or the liquid?
So vessel.
So everything will expand on heating if I'm not considering between 0 degrees Celsius to 4 degrees Celsius in case of water only. The rest of all object on receiving heat will expand. Is it clear? In
Yes,
case
sir.
of metal. So this vessel, since it receives heat first, so it will expand first. So on expansion, the volume of this particular vessel would slightly increase, and consequently, the level of liquid from this point would increase or decrease.
So decrease.
Good. So on heating, level of liquid in this particular vessel first decreases. Why? Due to expansion of vessel. Is it clear?
Yes, sir.
Now heat then transferred to this particular liquid, which on heating it expand, and hence level of liquid may rise from this point to some new point. So initially this level may go to this point to point B. So from A to B, it will be due to expansion of vessel. And on further heating, level of liquid may rise to this new point C. So from B to C will be the real or actual expansion of liquid. But you will observe only this point to this point, that is from A to C. Is it clear?
Yes, sir.
So you'll say on heating, since vessel will receive heat first, hence expand first. So level of liquid decreases. On transfer of heat to liquid, liquid will expand, and hence level will rises. So in this part, B to C is equals to A to C plus A to B. So B to C is the actual expansion of this particular liquid. So we can say this is real expansion of liquid. A to C is apparent expansion or false expansion observed by observer. So it will be apparent expansion, and A to B is expansion of vessel. So in all of different vessel, level of liquid or expansion of liquid will be always same. Only there will be change in expansion of vessel that will be different for different material. So just remember, a real expansion of liquid in all different vessel will be same. Rifra, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Next is calorimetry. So first, what do you mean by calorimetry? So you'll say the study of exchange of heat between any two different body or system, which results or which causes to change their temperature or change their state. This study is called calorimetry. So calorimetry is the study of exchange of heat between bodies or system which causes to change their temperature or state is called calorimetry. So principle of calorimetry is based on conservation of energy. So we can say principle of calorimetry, or simply it is based on conservation of energy. State heat lost by one body must equals to one body must equals to heat gained by another body. Ifra, any doubt?
No, sir.
Okay, just write it down. Now, to define this particular study, let me define you some basic terms related to this whole part. First is called heat capacity. It is simply the amount of heat required to raise or change the temperature of a substance by 1 degree centigrade at normal atmospheric pressure. So it is the amount of heat is required to change the temperature of a substance by 1 Kelvin or 1 degree centigrade at normal atmospheric pressure. So Q equals to specific heat or simply heat capacity times change in temperature. So S is called heat capacity constant. So its SI unit related to this relation will be joule per Kelvin. Next, if there is some specific term related to this particular heat in terms of mass, then it will be called as specific heat. Specific heat capacity. So it will be the amount of heat is required to change the temperature of 1 kg substance by 1 Kelvin or 1 degree centigrade at normal atmospheric pressure. So Q equals to mass of substance, specific heat constant times change in temperature. So this small s is called specific heat constant or capacity. So its SI unit related to this expression will be joule per kg per Kelvin. Now, there will be some constant value related to this expression. Specific heat capacity of ice and specific capacity of vapor both will be equal and equals to 0.5 calorie per gram per Kelvin. It will be easy to remember in terms of calorie, and then further you'll convert by 1 calorie equals to 4.186 joule, or you may write 4.2 joule. Ifra, any doubt?
Yes. No, sir.
Next, third one is called in case of water, specific constant will be 1 calorie per gram per Kelvin. Next is molar specific heat constant or capacity. So if the substance or the amount of substance is taken in terms of mole, that is in the case of gas, so it will define only in terms of thermodynamics. So in this part, I'm just defining the statement and nothing more. The amount of heat is required to change the temperature of 1 mole of gas by 1 Kelvin or 1 degree centigrade at given condition. Like in thermodynamics, we had different processes. So this molar specific heat had different value for the same gas in different process. So in general, it is equals to NC times delta T. So the C is called molar specific heat constant. So its SI unit related to this part will be joule per mole per Kelvin. Now there will be a relation between these two different heat which causes to change the temperature. If you relate heat required in these all different part, so on equating, you will get S equals to m times small s, which is equals to n times C. So capital S is heat capacity constant, small s is specific heat constant, and C is molar specific constant, where n is number of moles given mass by molar mass. Ifra, is it clear?
Yes, sir.
So these three different terms which causes to change their temperature, it will be the first cause of heat supplied to this particular system. Just write it down to this part. Okay. So in this part, we mainly have two different types of heat. First, which causes to change their temperature, and the second, which causes to change their state. So heat supplied or rejected may bring out two different sense. First, which causes to change the temperature of substance, and second, which causes to change their state. So for change in temperature, we mainly have three different heat. First one was heat capacity. Second one is specific heat capacity or constant. And third one in terms of mole, it will be molar specific heat capacity. And second part, heat which causes to change their state is also called latent heat. So first one will be latent heat of fusion. Latent heat of fusion, that is conversion of solid into liquid. In both ways. And second, latent heat of vaporization that is between liquid to vapor. So let me define you these two different heat. First is latent heat of fusion. It is the amount of heat required or absorbed during conversion of solid into liquid or liquid into solid at its melting point. You will say the amount of heat required to convert ice into water. Similarly, you will say the amount of heat absorbed during conversion of water into ice. Both will give the same result. So we can define this particular term in either way. So you'll say the amount of heat required or released during conversion of ice into water or in general, it will be between solid into liquid or liquid into solid at their melting point or freezing point at normal atmospheric pressure. Like in case of conversion of solid, so it will be melting. In case of liquid to solid, it will be freezing. Ifra, is it clear?
Yes, sir.
So in case of ice, latent heat of fusion for ice is 80 calorie per gram. Last one is latent heat of vaporization. So it will be the amount of heat is required to convert liquid into vapor at its boiling point and normal atmospheric pressure. So it will be latent heat of vaporization for vapor or water. It will be 540 calorie per gram. Ifra, in it out. Okay, just write it down. Now, related to these different heat, let me define you graph related to this conversion and some important term related to that part. So heat versus temperature graph. Suppose ice initially at minus 20 degrees Celsius or some, so on giving heat, it may reach to this point like this. So initially it was at this point, some minus 20 degrees Celsius, let's say. So on giving heat, temperature of ice will change from minus 20 degrees Celsius to reach at 0 degrees Celsius. So it will be specific heat to change its temperature from one temperature to some other temperature. Now at this point, it will tend to change state from ice to water like this. So at this point, it is in ice. Non-supplying heat, state of it may get changed to reach at this point and becomes water. This is called latent heat of fusion, that is conversion of ice into water at its melting point and normal atmospheric pressure. On further giving heat, temperature of water will start rising from 0 degrees Celsius to 100 degrees Celsius, let's say at this point. (100°C) temperature versus Q. So it will be again specific heat to change its temperature from 0 degrees Celsius to 100 degrees Celsius. On further giving heat, state of water will start changing from water into vapor till at this point. So initially being in water and now converted into vapor. So this is heat supplied or ejected to change state from water to vapor. And further giving heat, temperature of vapor will start changing like this. Ifra, any doubt related to this curve? Okay. Now in this part, we have three different change in its temperature. First one at this point, so there is some inclination, let's say theta. The second one is at this point, So there will be some inclination of this particular line with respect to x-axis, let's say theta 2. And similarly at this point, let's say theta 3. So there was first question in this entire curve, what will be the relation between theta 1, theta 2, and theta 3 for this particular curve? So let me define you what this particular theta or slope of this curve will actually define you. Since these three different curves are straight line representing specific heat, so we may write dq equals to ms times change in temperature. Now, in this particular curve, we have vertical line as temperature and horizontal line as heat. So take temperature to be in numerator and heat in terms of denominator. So on rearranging this particular equation, you may write dt divided by dq equals to 1 by m into s. Ifra, is it clear?
Yes, sir.
Now, this particular quantity, dt over dq, is nothing but perpendicular over base related to this particular curve, so which is also called slope of temperature versus heat. And this is related, according to this relation, as inversely proportional to specific heat of substance. Is it clear?
Yes, sir.
So from this part, we can say slope is inversely proportional to specific heat. So greater the value of a specific heat of substance, it will have smaller slope. Now, according to the above term, like for values of specific heat for these different substances, since specific heat of ice is equals to specific heat constant for vapor and smaller than specific heat capacity of water. Since the specific heat capacity of water is 1 calorie per gram per Kelvin, and for ice and vapor, it is 0.5 calorie per gram per Kelvin. So these two should be equal to each other and should be smaller than water. Now, according to the above condition, slope is inversely proportional to specific heat. So the lesser the specific heat, it will have more slope. It means theta 1 should be equals to theta 3 and it should be greater than theta 2. Ifra, is it clear?
Yes, sir.
Okay. Next question related to this will be, you'll be asked if you have water and vapor at same temperature, that is 100 degrees Celsius. So which one will cause more severe burn, water or vapor?
Sir, vapor.
So why? Just draw a vertical line at this point. So it will define you water or heat of water at this particular state. And if you draw a vertical line at this point, it will define you heat of vapor at this particular temperature, 100 degrees Celsius. So you will say at same temperature, 100 degrees Celsius, the vapor will have large or more amount of heat as compared to water in the form of latent heat of vaporization. That's why it will cause more severe burn at same temperature. Is it clear?
Yes, sir.
Similarly, you'll be asked at same temperature 0 degrees Celsius, let's say ice and water, which one will cause or which will be more effective in cooling, ice or water?
Sir, ice.
So again, related to this graph, just draw a vertical line at this point and a vertical line at this point. So you'll observe, since ice having more amount of cold energy, or you will say less amount of heat energy as compared to water at same temperature 0 degrees Celsius. So ice will be more effective in cooling as compared to water. Is it clear?
Yes, sir.
Now, third question related to this will be why there is no change in temperature during change of state, that is from ice to water or water into vapor. Ifra?
Sir, because that temperature is utilized in changing from one state to another.
Heat is utilizing in changing state. Okay, so temperature of the substance will remain same till whole substance get converted into some new state. Good. So first, at same temperature, 0 degrees Celsius, ice will have more cold energy or lesser heat as compared to water. So it will be more effective in cooling. Next one, at same temperature, 100 degrees Celsius, vapor will have more heat energy as compared to water. So it can cause more severe burn as compared to water. And next one, why there is no significant change in temperature during changing state. So you'll say, during change of state, heat supplied is utilized in breaking of bond, hence temperature will remain same. You just write it down up to this part. Now, related to this concept, how to solve any problem. First, try to draw the conversion or graph and then apply these different concepts to solve. Suppose first, if 10-gram ice at minus 20 degrees Celsius is find heat to convert it into 10 degrees Celsius water. Try to solve. Let me define you what would be the conversion graph related to this part. Let's say this is vertical temperature relation and this is heat supplied during this process. Since ice initially is at minus 20 degrees Celsius, so it will be at this point, minus 20 degrees Celsius. So it first requires this amount of heat to change its temperature from minus 20 degrees Celsius to reach at 0 degrees Celsius. So let's say this is Q1. So Q1 will be specific heat. So mass of ice, specific capacity of ice, and change in temperature, final temperature, minus or minus initial temperature. Further, it will require heat to change its state from ice into water. So it will call Q2, that is latent heat of fusion, conversion of state from solid into liquid. And further, to raise its temperature from 0 degrees Celsius to 10 degrees Celsius to reach at this point. So this will be Q3. Again, it is to change its temperature from 0 degrees Celsius, 10 degrees Celsius, so it will be specific heat. Now this ice get converted into water, so it will become specific constant water and change in temperature 10 minus 0. Just put all the values and try to simplify it.
Okay, sir.
Good, Ifra. Find amount of vapor or mass of vapor is required to raise 1,000 calorie heat on reaching finally to 10 degrees Celsius. It means we have steam or vapor which is initially at 100 degrees Celsius. So it may condense from vapor to water at 100 degrees Celsius. So it will release amount of heat during change state, let's say Q1. So it will be latent heat of vaporization. Again, on further cooling down, to change temperature from 100 degrees Celsius to 10 degrees Celsius to reach at this point. So it will be heat during change of state, that will be specific heat. So Q1 will equals to mass of vapor required times latent heat of vaporization, and Q2 is this mass M now converted into water times change in temperature. So 100 minus 10. Now we have total heat 1,000 calorie. Just add these two terms and equate it to 1,000 and try to find mass of vapor required. Ifra, is it clear?
Yes, sir.
Try to solve. Good, Ifra. Now, if you join these two different questions, so it will be like if 10 gram ice at minus 20 degrees Celsius mixed with 100 by 63 gram vapor at 100 degrees Celsius. So what would be its resulting temperature? So you'll solve like this. Is it clear, Fra?
Yes, sir.
Now let me give you a question related to this part. There is a question in NEET. If 10 gram water at 10 degrees Celsius is mixed with 20 gram ice at minus 10 degrees Celsius. Find the resulting temperature and amount. So let me define you how to solve this part. We have two different quantity. So one will lose heat and the other will gain heat. So let's say this is Q versus T. So we have initially ice at minus 10 degrees Celsius, this point. So it will first require to go from this point to this point. So it will require Q1 amount of heat energy to change temperature from minus 10 to 0 degrees Celsius. Similarly, we have water at plus 10 degrees Celsius. So it will release heat while going from 10 degrees Celsius to 0 degrees Celsius during this particular mix. So let's say capital Q1. So first find small q1 and capital Q1, then compare these two different heat. So according to their preference, we may define towards which side this particular may move forward. Is it clear?
Yes, sir.
Try to find small q1 and capital Q1. Small q1 will be mass of ice, specific capacity of ice, times change in temperature. And similarly, capital Q1 is mass of water, specific capacity of water, change in temperature.
Sir, both are equal.
Good. So is there any change in state further? So you will say no. Ice will tend to remain at ice, but at 0 degrees Celsius, and water to remain in water at 0 degrees Celsius. So finally, we can say for this, we will have 10 gram water and 20 gram ice, and temperature of both these two parts in equilibrium will be 0 degrees Celsius. There will no further change in its temperature or change state. Is it clear?
Yes, sir.
Okay, just write it down. Okay. Now, related to this part, there will be two different possibility. First, if small q1 will be greater, suppose, as compared to capital Q1, So small q is basically cold energy. So the difference of these two terms, that is Q1 minus capital Q1, this will be amount of cold energy left out in this particular system, which will tend to freeze some amount of water from 0 degrees Celsius water to 0 degrees Celsius ice. So this cold energy will freeze some amount of water. So mass will be amount of cold energy divided by latent heat of fusion. Is it clear?
Yes, sir.
Similarly, if capital Q1 will be greater as compared to small q1, so capital Q1 minus small q1 will be amount of heat energy left out in this particular system, which will tend to melt some amount of ice into water. So this heat energy would melt some amount of ice into water. So again, mass of ice to be melted would be Q1 minus Q1 divided by latent of fusion. Related to this mass, amount of water and ice in this particular mixture would change. Is it clear?
Yes, sir.
Okay, just write it down.